So now that you've seen the actual simulation of summing two or more sine waves, let's talk a little bit more about that property, and then I'll do some more examples. So we've got the oscillating term, and we've got the envelope term. And the envelope, which in this ugly picture above, but you've seen a good simulation of this now, is the dotted red line, and the envelope travels at some velocity. And what we call that is the group velocity. The envelope travels at the group velocity, whereas a peak, and the peak, depending on what we choose, travels at the same speed or perhaps a different speed, and I showed examples of both, than the group, and that's called not the peak velocity, but the phase velocity. It's actually called the phase velocity, but it's the velocity of the oscillating term. It's the velocity of one of those little peaks. So there's the group velocity and phase velocity, and the group velocity is just the velocity of this wave, and the phase velocity is the velocity of this wave. So you should easily be able to see that the phase velocity is therefore defined as omega average over k average, because remember, the speed of a wave is just omega over k, and the group velocity is equal to delta omega over delta k, right? It's delta omega over 2 divided by delta k over 2. The 2's cancel, so we're at delta omega over delta k. So we've got two different velocities, that's a definition, of the group velocity and the phase velocity. And jumping forward again to, how do we represent a particle? We represent a particle as a group of waves, So the group velocity of our wave function is what represents the velocity of the particle. The group velocity represents the velocity of the particle. And so actually you can get into some really interesting discussions, I'm not sure we'll have time to, which is the Einstein's declaration that nothing can travel faster than the speed of light. It's not actually that nothing can travel faster than the speed of light, it's that no information can travel faster than the speed of light, or nothing interesting can travel faster than the speed of light. And it actually comes down to the fact that it turns out that the group velocity can't be faster than the speed of light. But the phase velocity actually can. It can be faster than the speed of light. And without going into any details here, I'm just telling you that in a single phase that you cannot share any information. What I mean by that is that in a single phase you can't vary anything in order to share anything useful. It's kind of hard to explain. You have to have more than one phase, more than one phase, and therefore you have to have a group in order to share information. Anyway, the bottom line is that there's some super interesting stuff about the fact that phase velocity can be faster than c, but group velocity cannot. For fun, let's just do a couple more examples using the wave simulator, understanding that what the phase velocity is the velocity of one of the peaks, and what the group velocity is the velocity of the envelope.